Okay, so welcome everyone, and I'm pleased to see people being able to make it to the tutorial hours. So yesterday in class, in lecture, we had gone through some of the motivations for hierarchical modeling. Now, many of those motivations noted the importance of context and the idea that certain contexts in which a person might be located, be they schools, institutions of other sorts, might have active behavior associated with them. And placing a person within a certain environment can subject them to the actions undertaken by that environment. For example, interventions undertaken by a school or particular aspects of policy undertaken by a correctional institution or what have you. Within today's tutorial, I thought that we would go through the building of such a hierarchical model and explore how we can capture these aspects of nested context. This work will lay the groundwork for later lectures, which focus on the issue of multi-scale modeling, where some of these environments in which a person, for example, might be embedded, can have dynamics characterized using different modeling forms. For example, on the one hand, with forms familiar or most familiar with classic agent-based modeling, so transitions among discrete states, perhaps as captured via state charts, but then other aspects of context at different levels potentially captured with stock and flows for continuous dynamics on continuous variables, or characterized using aspects of discrete event simulation for workflow-based processing when resources are of greatest interest. So today, though, we're going to start with the basics of these hierarchical models, get our hands dirty, roll up our sleeves, and as time allows, build up a little model. So to that end, I'm going to share my screen here. And we are going to create. So we're in AnyLogic here. We're going to do File, New, Model. And we're going to call it Fields Academy, FA, hierarchical hierarchical transmission model. How far we are able to go will remain to be seen. We'll certainly get aspects of the context hierarchically, and with some good timing, we will hopefully be able to get some aspects of mobility and then infection transmission. The model time units here will be days, and I'm going to call this V1. I'm thinking that I might distribute this to people, and I want to be clear you're getting the right version. It's even possible I'll distribute it in the course of the next hour, and I want to be clear that you're getting the right version and allow you yourself to have earlier versions that might still work even if the latest one doesn't. Okay, so we've got this version 1 of it. What I'd like to do now is to go to main, and we're going to add in 2 types of agents here. So we're going to right click on project as a whole, new agent type, and we're going to add, as I say, 2 types of agents. The first is going to be a city agent. And the second will be a person agent. Both cases capitalized, as is the convention for agent types to distinguish. These are the sort of the molds out of which you build agents, the templates for agents, as it were. They characterize the properties of agents. Individual agents will be denoted with lowercase letters when we refer to them. This is a capital P person. Okay. Okay. Now, what I'm going to do now is go to city, and we're going to give it an appearance. Okay. To do that, having opened up this canvas here, we're going to go down to the presentation area of the presentation palette of the palettes menu. And we're going to put in place a rectangle, okay? And this is going to be of width and height 100. And I'm probably going to get that width and height wrong when adjusting it, so I'll adjust it via this. Well, I got pretty close. Here, for this small rectangle, we'll do width 100 and height 100, okay? And I've tried to center it at the origin here, just so it will appear around, symmetrically around the point that I select for it. So if I tell it to appear at this point, it will appear in a way that's centered around that. Okay. I did that by eye, but you can also do it by looking to make sure this is minus 50 and minus 50 here. Okay. So this is going to be an area in which agents will be visually placed. Next, let's go to person, and we've gone through this routine before. We're going to go down to the pictures area and put in a small image of a person there. And pardon me, I'm going to close this door here. Okay, so what have we done? We've added two agent classes successively, and we've gone and we've lent them each an appearance for city in this form, and person in this anthropomorphic form. Okay, save. Now, these representations are of sort of the characteristic of the agent. We've defined agenthood in a very simple form here in cityhood. We don't yet have populations of cities, so we're going to be adding them. But to do that in a fashion that's more principled, we're going to be going to the agent palette here, and we're going to parameterize this model. So rather than hard coding it, an anti-pattern in model development is hard code things, hard code the numbers that you're using directly into the model. A much more viable strategy, a much more scalable strategy, one that's more transparent, one that's more flexible for experimentation, is to parameterize the model by your assumptions. So we have to make some assumptions, but we encode those assumptions using parameters, in this case, that explicitly note this assumption and allow us to change it, in this case, across scenarios. So what we're going to do in main here is we're going down to the agent palette. We're going to drag in parameter here. And this is going to be count cities. And then we're going to be using that to set the number of cities. By default, I'm setting it to 5. So parameters in a given location, in this case in Maine, they encode assumptions, and they serve to communicate assumptions from the point of creation of this thing, in this case Maine, to where it's used. Here, the thing that creates Maine is in the scenario. So every scenario will be able to specify a different value for count cities. Okay, now, having done that, we are going to now go to projects. We're going to create a population of cities. How do we do that? We're going to go to the projects and drag in here a city. Okay, drag in the type city. I'm going to call it cities. And edit it in the in this parameters window, properties window, excuse me. Okay, now this set of cities will be encapsulated within this population. We're going to have a population of agents. Make sure population of agents is specified there. And then we're going to say count cities. Okay. 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 Next, we're going to distribute these cities around the space. So we're going to place agents, and we can choose to put in some formulas for where the agents go. I think I'll do that. I'll say the X location is drawn from uniform. It's a continuous uniform distribution for between 0 and space width, the width of the space. And I'll copy that for Y and make it for space height as well. And it's exhibiting problems. So this is a good, so I tried to build it complaint that it cannot convert from double to int. I know it involves that parameter, but I can show you how to find that. If you double click on that, it'll bring you to this place where it's complaining about its count of cities. And it's because I made a rookie mistake for this parameter. If you go to this parameter in Maine, what I neglected to do was to set it, excuse me, this parameter in Maine, to set it to be an integer. So you can set it to be an int here. So how did I do that? Well, I double clicked on this. It brought me to the point at which it was complaining. I note that it involves count cities. I go to the count cities parameter. I noted it was a double precision value. It should have been an integer. Okay, build again. It should not complain. Run it. Right click on that. And I said run. And we see that cities are scattered around. If we run it more than one time, we'll see they're at the same location. That reflects the fact that this experiment is using a fixed seed under randomness. I'm going to change it to a random seed so that its sequence of random numbers is scrambled each time, or is based on a seed that's very unlikely to be the same each time. And now each time I run it, I'll see some differences in the placement of said cities. Okay. So next, I'm going to configure these cities to connect to each other. Okay. So I'd like you to go to main, and I'd like you to go to space and networks. And I'd like you to set down in the space and network side. You may have to expand that. Again, I'm in main. I'm in space and networks here. Okay. And I'd like you to go to network type and do distance space. And I'd like you to set it to a distance space network of distance 300. If you run it now, oh, I'm sorry, I did not do a critical thing. I set it to have that to distance 300 for a distance-based network. What I did not do is make sure that network appears visually. So this will wire things up, but it won't necessarily display them. To make sure they're displayed, go to city, go view the connections for a city. And I'd like you to select this draw line connecting it and an agent. And we could use this line color. Okay, next. I'm going to, I built that. These cities will be in a different visual positioning, but they will exhibit connection to one another. In these cities, but at this point, square like geometric shapes. Population. Our population, per our earlier principle for approaching it, we're going to have it parameterize the city by its population. We're not going to hard code the population of each city be able to be set through a parameter. So I went to the agent palette. I dragged in a parameter to city. This is going to be called population size. I'm not going to repeat that mistake again. It's going to be an integer. And I could put in a specific default value. Maybe I'll say on average, or maybe I'll say make it 100 people in the population within that city. And then, given that I'm looking at the city and I have a population size in terms of a count of people, I now need to add a population of people. To do that, I go to population, drag in person here, and set it to population. Should be a population of agents with the initial number of agents given by the population size. Okay. Now, here, we're going to go and place people within this city around that environment. Okay. So we're going to be distributing these individuals around them. Now, there's a couple of ways. One of them would be for the city as a whole, we could specify we're going to have a random location. But we would have to set the space dimensions and widths accordingly. And what's going on right now is that it's setting a width and height of people in that city for a much broader area. Now, we could say, okay, we'll put them within a distance of 100, but it'll be such that that won't be exactly what we want. I'll go and show this. So I'm going to put people at random locations here. I'm going to have them set up so that we have a distance space network, and we will have a connection range here, distance space network of connection range 15. Okay. Okay. So here we go. What did I do? Let's rehearse it. I was in city. I went to the properties of city. I went down to space and networks. I set it to be a random layout type. I set the height and width of the space to be 100 with an asterisk we'll come back to. The network type to be distance-based and the connection range to be 15. People will be wired up into connections. But those connections between people won't yet appear for the same reason that initially they weren't going to appear for cities. To make them appear, we're going to need to go to person. And in the same way we did for city, we're going to have to set their connections and say we're going to draw a line connecting agents. And we will make that line a different color. We'll make it blue. Okay. So here we go. We're going to build early, build often, and we're going to run. And we're going to see what I mentioned before. So we do have people here, and if I go and zoom in, you'll see it with greater clarity. We have people wired up to each other within each city, but their locations are offset from those of the city. And it's actually because of how I set up the city rectangle being centered there. It was centered at the location of the city logically, but it's actually placing people in a square to the lower right of that. So I am going to, there are several ways we could fix this, some of them deeper than others. I'm going to simply move it in this fashion. So it lies to the lower right and lower left. It gives you a sense of where the coordinates are. It starts laying people off with that designation. So here we go. It's going to probably lead to the roads coming into the corners, but we can bear with that. So now people are gathered within cities. People are in blue networks within such cities, and the cities are still connected, albeit in a way to their upper left corners. And I hope you'll forgive that aesthetic shortcoming. Okay. So we have populations now within cities and cities within the overall environment. Now, population members here are quite passive right now. Although the environment is full of sound and fury, we really don't have a lot of things going on with the agents in terms of agency, in terms of acting. And we'd like to remedy this. Okay. So what we're going to do now is feel free to be encouraged also to communicate on the Hangouts or the chat, right? Because others may have the same issue. Maybe you could. I see. Yeah. Yeah, you need to put it to the lower right of that. Yeah. It's a kind of silly thing about how any logic lays things out by default with positive X and positive Y as measured by this. Positive Y is going down, positive X is going to the right. This is a long-standing computer science convention that is of questionable depth. Okay, so we're going to add some behavior to a person. We will start by adding an event for a person. I did so from the agent palette, adding an event. And this will be called migration event. Okay. And we are going to have it go off at a certain rate, a hazard rate, a chance per unit time. It's not a probability, it's a probability per unit time. So it might be 0.01 per day, 1% chance per day. Even in a half-day period, they have some chance. And the rate here will be so that they move once every 3 years. So I'm going to put 1.0 divided by 3.0 times year. Okay, now this times year construct, this allows me to express a year worth in whatever unit of time I have for the model. In this case, time is days. So this will be approximately 365.2526. And you'll notice, excuse me, 2.24, I think. And so this will be 1 every 3 times 365 or so. So it'll give a chance of, on average, someone to move in about every 3 years on average. Now, that's the rate here. This event will be going off in the rate. A more significant thing yet will be to actually move them so that this person moves among these locations. And what we're going to do here is we're going to get a destination city for them, and we're going to move them to that destination city. Okay. And we're going to put this in the action area for this event. So an event's job in life is, when triggered, to undertake some action. And the action is dictated by code. And you have some affordances here to understand something about, for example, what event is firing. We're going to put in code that will move this agent. So the first thing we're going to do is we're going to figure out to what city they wish to head. Okay, so we're going to say, okay, we're going to have a destination city. Here we go. And that destination city is not going to be a randomly selected city. It's going to be a city selected by virtue of being connected with this one. So we're going to say, we're going to use the city in which they are located. This is where hierarchy comes in. So this person we're dealing with a person. They're in a city, and that's provided to us as something here. It's the city in which they're located. We're going to say city, and then we're going to get the connections of that city. So every city has a set of connections. You may recall that some time ago we went and we told it to draw those connections. Here we're going to be using those connections to give us some information. So we're going to say city.connections dot, and we're going to say get, and I'm going to press Control space, get random connected agent. Okay, so it's this one here, get random connected agent. So I'm going to be getting, so I'm in a city right now as an agent. I'm going to get, given the connections of my city to other cities, I'm going to draw from the cities to which my city is connected with equal probability, uniform probability. Okay, so I've gotten what I believe is a city. Now, we are now going to go and check, did they in fact get a valid city? It is possible that this model is being run with a single city and it's not connected to any other city. So here we're going to check if this destination city actually exists. So the way in which we do this is we're going to ask, is it referring to any city? So we'll say if it's not equal to null. Okay. Only if it's not null, only if we are referring to an actual city, will we be able to go to it. Otherwise it wouldn't be actionable. Okay, if the city is not null, the destination city that we've obtained, then we will go to it. So I'll say this dot go to population. And it's going to need to know to what population I'm going. Well, it's going to be the destination city dot population. You may say, well, where did that come from? The destination city's population. Well, every city has a population. We're going to, right now we're in the population of our current city. This person is in the population of our current city. Here we're getting a destination city from among the randomly selected connections. So, among a randomly selected connection, we're going to get the destination city for it. And we're going to add ourselves to that population and remove ourselves from our current city. So that's the plan. That's the plan. Now, I'd kind of like to mark, if I could, if I may, the individuals who have moved. Just visually, I'd like to be able to see people's movement. And we're going to come back and do some fix up. But I think it would be nice to see them as kind of tracers spreading threat so we can clearly see. So as a little exercise here in person, we're going to go to the agent palette. We're going to drag in a variable, and it will be called color, spelt in the appropriate manner. And it will be of type color, spelt in a less appropriate manner, a manner dictated by the hegemon. And we're going to set it to be black. Okay. Some may wish to set it to orange, but we're going to have it in black. And next, we're going to go to this little anthropomorphic object. And because it's kind of hard to frob in an easy way with this, we're going to go to person, go to presentation, go down to this level thing, go down to person, and we're going to, again, engage with the shape body component of this. And we're going to set the fill color to be whatever the color is, okay? Whatever is given by this variable color. In other words, this little anthropomorphic object, how did I get that? I went down to person, went to presentation, went to level person, and I went to shape body. And then I went under appearance and shape body, and I had it refer to this variable. Whatever color the variable holds will be the color of this, the filled color, the filling color for this anthropomorphic image. Okay. So initially be black. Next, we're going to go to migration event. And when they move, we're going to change this agent. Remember, the agent shifted population. We're still referring to the agent here. We're still dealing with the agent. It's just the agent has moved populations. We're going to turn their color. This dot color equals magenta. I think that will be rather, oops, sorry. That equals magenta. I think that's should be a valid spelling. No. Oh, okay. So, oh, I see. Did I not? Okay. So what's going on here? Cannot convert from agent to city. Okay. Okay. Oh, okay. 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 There's a better way to do it. Thank you. So it's complaining about this. It's saying, hey, I'm getting you an agent, and you're claiming it's a city. How do you know it's a city? And there's two ways to deal with this. Principled, one is more brutal. I'll show you the brutal one first, just so you're aware of its existence. You can cast this to city. You can, in other words, coerce it. You could say, hey, look, I know it's a city, and you better turn it into a city. And that's kind of a crude, it does work, but it lacks finesse. And I'm going to show you a way that's more aligned with Canadian values, okay? Okay, so we're going to go to the city here, and we're going to tell it the connections here are connections amongst cities. This is type safe. This is actually giving it information that's substantive. Cities aren't connected to arbitrary other agents like people. It's not like there's a road from one city to a person, you know. It's It's cities are connected with cities, and by the same token, persons are connected with persons. They're not wired up to cities. They're connected to persons. Now, this is the principled way to deal with it. This we've actually added information. We've told it that the network amongst the network associated with a city is connected to another city. It's not connected to just any old thing. It's not like it's scrambling of different types of agents in the same city network or the same person network. Okay. Having done that, we should be able to build and we should be able to run. And here we go. We will see our population of agents. And if we move, we will start to see people appearing, so people disappearing as black and appearing in magenta form. Who are those people appearing in magenta form?
Agents who have moved from
They've
one city.
agents who have moved from one city to another. Now, one thing that you may note is that those agents are not necessarily wired up properly to be close to to be linked up with people next to them. So in order to link them into the new network, some of them do appear to be connected, but others not. And it's certainly not a uniform thing. You can see there's people right near each other here that are not connected. So we're going to actually knit them into the network properly, do them justice, our magenta friends. Okay, so here we go. We are going to complete this thought per person by taking this migration event. And if they've migrated, not only are we going to change their color, more significantly, we're going to take this destination city and we're going to apply the network to it. What that means is we're going to tell it, hey, reconfigure your network to account for your updated population. Okay. Okay. Now, build early, build often, run early, run often. So I'm going to run this. And now we're going to see similar overall behavior, but you should start to notice that these individuals who are magenta in magenta colors are also wired in pretty uniformly to the network. You could see them wired in as individuals in the network. But this high-level depiction, sometimes the network is sort of hidden under people, but it does seem to be linking up individuals who are nearby. So this gives some appearance as to how often mobility is occurring. And as such, it's rather pleasing. We're going to stop this. I'm going to call this now, complete that as version 1, and we're going to be going on to version 2. Is there anyone who would like me to post this? Anyone in the chat like me to post this to the course site? Okay. Oh, was that a request there?
Yes.
Okay, great. Okay, give me a moment here, and I will Okay. Go and, oop. Okay, so this is exhibiting unhelpful behavior. Okay. Yeah. Okay. 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 And this is models for exploration, and then models built in class. I'll do this. So this will be hierarchical mobility model V1. We're going to go put it in. Okay, why am I not seeing it among my? Okay, there we go. I'll put it as V1, and there we go. There you go. And save and display. Okay, it's done. Okay, so back to business. Okay, we have about 13 minutes left. I think what I'll do is I think we can do it with. We're going to add in some interagent communication of infection. Okay, so what we got to do, we got to do it in double time. Here we go to person. We're going to go to agent. We're going to put in a state chart. This can be infection state chart. Put in a state susceptible. Put in a state effective. Put in a state recovered. We're going to put in transitions. Oops. Okay. Now, this transition, I'm going to show the name. And this will be called new message. Just yes. Okay. This will be called infection. Oops. Hey, come on. Infection. This will be triggered by message arrival unconditionally. This transition will be recovery rate, be called recovery. Show the name. We're going to leave it as that rate for the moment. We'll fill this in. We're going to have a transition back to susceptible. There we go. And this is going to be called waning of immunity. Show the name. And again, it's going to be a rate. And we're going to set its rate in just a minute. Okay. Next. I'm holding this down. We can adjust that. Okay. Next. For main, we're going to add, I'm going to teach you, I'm going to learn you a principle or two with this. Okay, so this parameter will be called contact rate. Okay. And it's going to be I'll say, yes, 10 times per day. Okay. Next parameter is going to be called mean recovery time. It will be some number of days. I'm going to say 5 days. And next, there's going to be mean duration of immunity. And that's going to be 365 days. Do 365.25. Okay. Okay. Right. I don't think we'll add probabilistic infection here just because of the time. We only have about 8 minutes left. Okay. So go back to person. Here we have infection. Recovery, the rate is going to be 1.0 divided by mean recovery time, but we have to go to main dot mean recovery time. We put those parameters in main recovery time. I should have probably emphasized the parameters were here in main. That's valuable because they are shared across agents and because we'd like to be able to change them as change our assumptions about them from scenarios. So this is 1.0 divided by mean recovery time here, but in main. Okay. Main dot mean recovery time. If you put them in here, you can cut them and go paste them instead into main and put this. Next, waning of immunity. Time ticks on. 1.0 times main dot mean immunity duration. Mean duration of immunity. When we have a rate, value of the rate for a memoryless transition. In the meantime, will be 1 over the rate. They're in inverse relationships. It's a basic thing about stochastic processes. It's related to the fact that if we have an exponential distribution of residence times, the probability of remaining in it goes down as 1 over the mean time in it. Okay. So here we go. Next, we're going to need a transition from infective to itself. Here we go. This is going to be called contact. This is going to be dictated by the rate. It's going off at a certain rate. What rate? Main dot contact rate. Contact rate. We just created that parameter. Let's, for good measure, change these colors. Not that it has impact, but I'm going to change this to lime. I'm going to change this to red, and I'm going to change this to gray. Next, I'm going to change color here. So when people are in the susceptible state, I'll set their color equal to lime. And then you need a semicolon because you're telling, do it, change the color. When they enter infective, the color will change to red. with a semicolon as well. And when they enter the recover state, as you'd imagine, the color will change to gray. Okay. Okay. Now, this self arrow, we have to fill in the logic. Right now, it's just going off at a certain rate in some sort of, isolated way. So this is amongst the core logic. We're going to set this to send to random connected. We're going to send a message infected exclamation point. Now, that's bad form. Had I 5 minutes more, I'd add an option list so I don't misspell it each time. But here, I'm just sending it. I'm not depending on it as a string to determine what to do. So if I had to make transition to make infection probabilistic and distinguish between something that forces someone to be infected versus something that is with a certain probability they're infected, I would go and correct this. But I will nurse my wounds to my conscience in putting that. Go on and plow on. Okay. Send to random infected. It's sending it over their connections, I might add. The final thing we have to do, well, there's two things. First, the migration event, we're changing their color to magenta. I'm going to comment that out with these two slashes just because we want to see their color dictated by their infection status, not their migration status predominantly. If I had more time, I would set it to cause them to have a different color for their border or something like that. But time is short. We're down to the crunch. Okay. And next, we go to main. And we are going to set up an initial event. This could be called initial infection event. Boom. There it is. It's a timeout event. It occurs once at time 0. And what does it do? It sends an infection message to a random person. How are we going to do this? Well, it's a good question because we have people in cities now. So we're going to go to, this is what we're going to do, cities dot get random. Okay, sorry. Random. We're going to get a random city. Then we're going to go to we're going to ask it deliver to random agent inside the city. I actually think we could do it better. Let me forgive me for just a sec. I'm going to say population dot random. Here we go. Random. There we go. So this is going to give us a person, a random person in this population. And we're going to say, we're going to send to that person. Okay, so here, pardon me as I just do this, I'm going to say send, excuse me, send. I'm going to send an object to a certain, or a message to a certain. I'm going to say, infected, exclamation point, and I'm going to send it to that person. Cities.random, that's going to get me a random city. Get the population of that city. Get a random person. I think young people call it a rando now, if I'm not mistaken. So this gets a rando. Okay, so it gets a rando, and we're gonna send that person they would call a rando a message. I guess that's why they're sending the poor guy a message. Okay. Um, okay, so now let's see if we can get this working. Oh, my goodness. Okay. Um, ah, okay. So so it looks like infection did spread to 4 of the 5 cities. Here we go. Now we're gonna run it again. It almost looks like it's spreading to almost everyone in the first city. Not just some rando. uh, you could see it spreads very quickly once it's in a city. Mm? Or it tends to. And it depends on how quickly people migrate, whether they migrate in time to infect other cities. Sometimes it dies out before by spreading within a city before it actually spreads effectively. Okay. Hey, no. Okay. Get me out of here. Okay. Yeah. Okay. Well, we have a little infection transmission in a hierarchical model with mobility leading to spread of infection among different jurisdictions, sometimes leading multiple jurisdictions to be reached by the infection, sometimes so the mobility process is competing with the recovery process to determine whether or not it indeed spreads to different locales. If we had more time, what I would have done is I would have gone to cities and I would have drawn the population size to be a uniform distribution between between 100 and 500. And this would mean that some cities are much larger in terms of, so pardon me, uniform DISC, discrete from 100 to 500, excuse me. So it's uniform discrete is going to draw an integer from that, and it's going to allow some cities to be very crowded, very dense, far larger, and some cities to be comparatively thinly populated. And this is going to lead to some different dynamics in terms of the persistence of an infection within a given city, and thereby giving it time, if it persists longer within a city, giving it time to spread before it dies out in that city. Okay, that's all we have time for today, folks. I will look forward to seeing you in class tomorrow. I will post this version of the model to the class site. Take care.